The calcium metal crystallizes in a face-centered cubic unit cell. In ideal solution, the intermolecular force of attraction between AA and BB will be same as that of A and B. The collisions are effective only when the molecules possess an energy which is greater than or equal to the threshold energy. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last session, we were discussing about the model question paper which has been released from the Pre-University Board. Now, let us continue with the part D which has been raised the question from the physical chemistry as well as from the organic chemistry. So, the first 5-mark question in the part D is, it will start with the physical chemistry and the question will be goes like this. Calculate the packing efficiency in simple cubic lattice. As we already know that from the solid state unit, we can expect a 3-mark question and it will comes in the 5-mark part, and you must know that 5-mark part will be divided into 3 plus 2, okay, or 2 plus 2 plus 1 or 2 plus 1 plus 1 plus 1 also, okay. So, here we have a question to write the packing efficiency. So, if they ask for the simple cube or if they ask for the BCC or if they ask for the SCC. So, this is for SC for the simple cube. If they ask you to write for the body-centered cubic unit cell or for the face-centered cubic unit cell, first thing is you must know how they will evaluate, okay. For writing the cubic structure along with the derivation part of A, that is nothing but a edge length, and also for writing the packing efficiency formula, substitution with the percentage, you will get an 3 marks, okay. So, what do you have to write? First thing is you have to write the cubic unit cell of simple cube or BCC or FCC, then derive the equation up to A, that is A stands for the edge length, then write the packing efficiency formula, then substitute and get the final value or write the final percentage. This is how they are going to evaluate it, okay. So, here as we all know that here they have asked the question on the simple cube. So, first thing I have written a structure of a simple cube where you have to say that these two are the edges, that is H and A. So, they are colliding with each other, okay. So, A is the edge length of the whole cube. This is your edge length between the two corners, okay, and R is the radius of the particle. So, you can call this point as R, okay. This is the radius. Then we know that A is equal to 2R. So, for the simple cubic unit cell, we know that it consists of only one atom. So, volume of the cubic unit cell was given by 4 by 3 pi r cube, and we know that volume of the cubic unit cell is nothing but A cube, correct? So, if you substitute the values, you will get 2R cube, which is nothing but 8R cube. Then write the packing efficiency formula. Then substitute how many spheres are there in a BCC, FCC or in the simple cube. Then add the values. Then write the direct percentage. You are going to get 3 marks. We'll discuss with the second question, and the second question is also from the solid state, okay. Here we can expect one numerical based upon the density. Let us understand what is given now. The calcium metal crystallizes in a face-centered cubic unit cell. So, it is given that it is nothing but FCC. For FCC, we know that number of particle is nothing but 4, correct? With the edge length, they are also given. Edge length is nothing but A, that is 0.556 nanometer. Calculate the density of a metal. Atomic mass of the calcium is given, that is 40 gram per mole, and also they have given the Avogadro number. So, you know what is that value, and we know that for density the formula is D is equal to Z into M divided by A cube into Na. What is Z here? Z stands for the number of particles in simple cube, BCC or FCC. Since they have mentioned that, we have to take down the example of FCC. Number of particles which is there in FCC is 4. And what is its atomic mass of the calcium? It is given, it is 40 divided by, what is A here? A is nothing but your edge length and it is given in nanometer. I will convert it into meter. So, I can write this as 0.55 into 10 to the power of minus 9 meter, and I can shift 1 point, I can get it as 5.56 into 10 to the power of minus 8 centimeter. Okay. So, now I will keep this value 5.5 into 10 to the power of minus 8 whole cube. What is Avogadro number here? So, it is 6.023 or 22 into 10 to the power of 23. Okay. So, finally, if you substitute these value, you will get it as 1.59 gram per cm cube. 1.59 gram per cm cube is the answer, that is the density of the given cell. Okay. Next, vapor pressure of the benzene is 200 millimeter of Hg and the solutions which is having 2 grams of non-volatile solute in 78 grams of benzene has a vapor pressure of 195 mm of Hg. Calculate the molar mass of the solute, and the molar mass of the benzene is also given, that is 78 gram per mole. Now, I will write the formula to calculate the vapor pressure, which is one of the qualitative property, correct? That is P naught minus P divided by P naught, which is equal to WB into MB divided by MA WB into MA divided by MB into WA. So, what is P naught here? It is already given that is a vapor pressure of the benzene, that is 200 minus, what is its pressure after adding an solute, that is 195 divided by 200 is equal to, what is WB here? They have given that it is a 2 gram of non-volatile solute. So, what is a gram of the solute they have taken? That is 78 divided by, we need to calculate what? Molar mass of the solute, and what is the molar mass of the benzene here? 78. So, now what I will do? I will do the simple cross multiplication, that is MB is equal to what? So, MB is equal to 2 into 78 into 200 divided by 200 minus 195 is 5 into 78. So, if you do the simple calculation, you will get it as 80 gram per mole. 80 gram per mole. It is the simplest calculation. For doing this, you will get an 3 mark. Next question. Write the two differences between ideal and non-ideal solution with respect to intermolecular interaction between the component and change in enthalpy. So, most of the time, not even they will ask the direct differences between the ideal and non-ideal solution. We can expect with respect to the particular factors. Okay. Here, they have made us to write the differences with respect to the intermolecular force of attraction as well as with the change in enthalpy. Let us go with the ideal solution first. In ideal solution, the intermolecular force of attraction between AA and BB will be same as that of A and B. Whereas in case of non-ideal solution, the intermolecular force of attraction between AA and BB will not be equal to the interaction between the A and B. Coming into the change in enthalpy, during the ideal solution, the change in enthalpy will be always equal to 0, which means to say that there is no change in enthalpy, we can say. Whereas in case of non-ideal solution, there will be a change in enthalpy and it is not equal to 0. Next, for a given equation, that is copper plus silver, which is going to form copper 2 plus and Ag, E naught of the copper and E naught of the silver, which has been given. Calculate the standard cell potential and write the cell representation for the above reaction or above equation they have given. Correct? So first I'll go with the calculation with the standard cell potential. We know that standard cell potential is given by a formula E naught of the cell is equal to E naught of the reduction cell minus E naught of the oxidation. So in the given equation, I'll write down that equation once again. So that is copper is going to oxidize to copper 2 plus, whereas silver, which is get reduced to silver in the +1 oxidations to Ag, correct? So copper is undergoing oxidation, whereas silver is undergoing reduction. You must know which side is undergoing oxidation and which side will be a reduction. Now, based upon the equation, I can substitute the E naught value of the reduction side. Where it is undergoing the reduction, that is silver is undergoing the reduction whose value is plus 0.80 minus oxidation is nothing but your copper, where it is oxidizes from the 0 oxidation state to +2, correct? So whose value is 0.34 volts. If you subtract this, you will get 0.46 as a standard electrode potential or a standard cell potential. Which is the second step we have to write? We have to write the cell representation for the above equation. So cell representation, as we know that. So first I'll go with the anode side where always oxidation will take place, and at the cathode side that is a reduction which is taking place, and you can remember this code also, AOL and CRR. Okay. So A stand for anode oxidation, that is a loss of electron, whereas the C stands for cathode reduction, and it is where the addition of electrons will be taking place. And remember how to write, and this is stands for left side and this is will be stands for right side also. You can consider in your own way. Now I'll write the cell representation now. Which one is undergoing the oxidation now? That is a copper. So copper bar copper +2 double strands silver to silver. Okay. This is a cell representation of the above equation which has been given. Next question. Name the cathode in the lead storage battery and write the discharge reaction taking place at the cathode. So here we know that in the lead storage battery, at cathode we always use the lead dioxide. Which one we are using? Lead dioxide as one of the major cathode. And at the cathode, you know, lead dioxide, when it is treated with an acid, in presence of an acid, it gives rise to the PbSO4, that is lead sulfate, with the formation of water vapors. Next question. Derive an integrated rate equation for the first order reaction. Remember, this is a question from the chemical kinetics, that is a unit 4 in the physical chemistry. Either you can expect the integrated rate equation for the 0 order or the first order. Both will come for the exam. Either any one can be asked, and those two are the important question too. Okay. Remember, if they ask you to write the integrated rate equation, write in your own way that a reactant is going to form a product and write the rate for the given equation that you have considered, that is rate is equal to minus dr divided by dt, which is equal to k into r, because we are writing the rate of the reaction only for the reactant, not for the product. So when we write this dr divided by dt rate equation, I can just rearrange this and I can write it as dr divided by dt is equal to k into R. So now for this equation what I'll do, I'll integrate on both the side. You'll get integration of dr divided by dt is nothing but ln R into kt minus kt plus I. This I will stands for integration constant, or you can say it is a constant of integration. Okay. Then at time 0. So at time 0 if I consider a condition, what will happen? So R will be equal to R naught, which is nothing but an initial concentration of the reactant. Now I will substitute this getting a value of R in the above equation. You will get ln R naught is equal to I. Now by getting in value of I will substitute to the original equation. You will get ln R is equal to minus kt into ln R naught, or if I take out kt outside, ln R naught minus ln R, and I can rewrite this as k is equal to 1 by t into ln R naught divided by R. Since we know that it is in the ln, we can convert it into logarithm by multiplying with a 2.303. If you multiply this, finally you will get k is equal to 2.303 divided by t into log of R naught divided by R. Next question, what are the two criteria for the effective collision according to the collision theory? There are mainly, we must understand what is mean by effective collision first of all. If I say it is effective collision, collision leads to the formation of product, and number of effective collisions are governed by following factors. One is by energy barrier and the one is orientation barrier. What is mean by energy barrier? The collisions are effective only when the molecules possess an energy which is greater than or equal to the threshold energy. If the energy of the molecule is greater or equal to threshold energy, then energy barrier will be breakdown, so it can easily form a product. Whereas orientation barrier, the reactant molecule must collide with each other in a favorable condition or in the favorable orientation, we can say. Okay, to facilitate the breaking of old bond and making for the new bond. So this orientation barrier, it has to overcome in order to react the two reactant to break down the older bond and to form a new bond. These two are the two factors which causes a effective collision, and these two barriers, if we overcome, the collisions will become more and more effective too. Next question, give any two differences between the lyophilic and lyophobic colloid. So this is a question from the last physical chemistry unit, that is the surface chemistry. So here any two proper differences you can write it off for the final exam. I have listed out the 5 differences. Any two proper one you can choose and you can write it. These are easily found by direct mixing, whereas lyophobic colloids are usually prepared by specific method, and we can reverse this reaction, and whereas the lyophobic colloids, once it is formed, we cannot reverse the reaction. Next question, explain the heterogeneous catalysis, give an example or give a suitable example. A heterogeneous catalysis in the sense, remember the reactant, product and the catalyst which has been used for the carrying out the simplest reactions will become different. Those type of reactions are said to be what? Heterogeneous catalysis. So if the catalyst, the reactant and product are in the different phases, then it is said to be heterogeneous catalysis. Here you can take the simplest example where sulfur dioxide, where it is again reacted with an atmospheric air which containing an oxygen which gives to the sulfur trioxide. You can see that all the reactant as well as the product, it can be in the same state or it can be in the different state. Next question, why do the colloidal solution exhibit the Tyndall effect? So as we know that Tyndall effect is nothing but a effect which we can see only in the colloidal particle. The reason is the size of the colloidal particle. The colloidal particles exhibit the Tyndall effect because of the nature and its size. The size of the colloidal particle is vary from 1 nanometer to 1000 nanometer, such that it can scatter the beam of light by a medium which are containing a small suspended particle. Hence, we can say that it can show the Tyndall effect. Next, in the part D only, there is a 6th main which is mainly meant for the organic chemistry. The question will be goes like this. Discuss the SN2 reaction mechanism by taking methyl chloride as an example. We know that SN1 mechanism is observed only in the tertiary butyl bromide, whereas SN2 mechanism will be observed in methyl chloride, that is a primary alkyl halide. So we know that in the methyl chloride, that carbon atom is attached with an halogen, correct? And when the nucleophile it attacks from the back side, you know what will happen? It forms an intermediate product, okay? It is unstable, where it easily leaves an halogen, because halogens are easily leaving group. It forms an alcohol. The name of this alcohol is methyl alcohol by leaving the halogen. This mechanism which follows a second order reaction, hence it is known as what? SN2 reaction mechanism, that is substitution nucleophilic second order reaction. Okay, because the reaction which is depends upon the concentration of the both the reactant as well as the nucleophile, hence it is a second order reaction. Next question, name the organic compound which has been formed when ethyl bromide reacts with the following reagent. When ethyl bromide reacts with the potassium nitrate, it forms a ethyl nitrite plus Kb. Okay. Next, when a ethyl bromide, when it is react with the silver cyanide, it forms a ethyl isocyanide. So like this, you know, any named reactions can be asked from the chemical properties of the haloalkanes and haloarenes. So next question is, what is mean by asymmetric carbon? Here I have not put the any answer. Let me understand what is mean by asymmetric carbon again. So asymmetric carbon in the sense, the carbon which has been attached with the 4 different atoms or 4 different groups, then it is said to be what? Asymmetric carbon. I will take up with the carbon 1, where it is attached with the different functional group. Okay. You can see now, this is a single carbon atom attached with the 4 different groups as well as the atom. Then only such carbon atoms are said to be what? Asymmetric carbon atom. Okay. Next, what does ethyl alcohol reacts with? How does ethyl alcohol reacts with the copper at 573 Kelvin, and write the equation. So here they are already given the ethyl alcohol as a reactant. So you need to write the ethyl alcohol, and which is the catalyst they have given, that is a copper or silver at very high temperature around 573 Kelvin. You know what will happen? Ethyl alcohol is get reduced to acetaldehyde with the evolution of hydrogen gas. Okay, that reaction is from the alcohol chapter. Next question, explain coal-base reaction. So we all know that this is also one of the important question from the alcohol, phenols and the carboxylic acid, and this question is from the phenol part. Okay, when phenol is treated with a base, it forms a dry sodium phenoxide in presence of an carbon dioxide at very low temperature, that is at 143. It forms a sodium silicate. Once the sodium silicate in presence of an acid, when we treat, you know, it forms a salicylic acid, which we call a 2-hydroxybenzoic acid, and this reaction was given by coal base, hence it is known as what? Coal base reaction, and it is one of the important named reaction too. Okay. Next, what is the IUPAC name of ethyl methyl ether? Let me write the structure now. So it is ethyl methyl ether, CH3O, CH2, CH3. I can write the IUPAC nomenclature for this, that is methoxyethane. Methoxyethane is a IUPAC name of ethyl methyl ether. Okay. Next question. Explain the mechanism of addition of HCl to the carbonyl compound. Remember, in the addition of HCl to the carbonyl compound, In the first step, the cyanide ion which carries the negative charge will attach to the carbonyl group to form a alkoxide ion, and in the second step, protonation of the alkoxide oxygen will take place to create cyanohydrin as a product. So, when we take the HCN and if you treat it with any of the alcohols, it forms a CN minus and it will forms what? Water. So, this cyanide nucleophile, it can attach for the carbon, where the carbon along with an oxygen which is having a double bond will shift its a bond to make the charge as equal. When the cyanide ligand attacks to this carbon, it forms a tetrahedral intermediate. Upon protonation, it forms a cyanohydrin product. This is a general reaction which I have taken down to show that how cyanohydrin product can also be formed when the HCN is attached towards a carbonyl group. Next question. Write the chemical equation for the benzaldehyde with acetophenol in presence of dilute alkali at 293 Kelvin and give the name of the major product which has been obtained in the reaction. So, as I said, it is a question from the alcohol, phenols and a carboxylic acid. So, here I have taken the example of benzaldehyde, because in the reaction only they have mentioned that benzaldehyde, when we react with the acetophenol, what will happen? In presence of very dilute acid, you can see that benzaldehyde is not having alpha hydrogen, even acetophenol is not having the alpha hydrogen. In presence of a dilute acids, what will happen? There is a simplest molecule called as water molecule which has been eliminated out. There it forms thereby it forms an ketol. Ketol in turn, it loses a water molecule and forms a transchlorine which we call as benzyl acetophenone. Okay, benzyl acetophenones are formed. This is how, just by taking in benzaldehyde with acetophenone in presence of very mild base, we can expect the benzyl acetophenones are formed. Next question. The pKa value of 4-methoxybenzoic acid is greater than the 4-nitrobenzoic acid. Which amongst them is a stronger acid? Okay. As we know that 4-nitrobenzoic acid contains a NO2 group which has a electron withdrawing group. NO2 group is what? NO2 group is a electron withdrawing group, resulting with higher acidity than the benzoic acid, and greater is the acidic character, lower will be the pKa value. So, the pKa value of the 4-nitrobenzoic acid is lower than that of the benzoic acid. That is mainly because of NO2 group which is an electron withdrawing group. Explain the carbolamine reaction with a suitable example. So, here this question is from the amine chapter, that is organic compound which are containing a nitrogen. Since it is a direct question, remember, please go through with the reaction and try to write with your own explanation. Here, primary amine in presence of an base and a chloroform, if you heat it, it forms a cyanide complexes which we call it as carbolamine or isocyanide complexes with the formation of KCl and water, and this test will be used to test only for the primary amine. Secondary and tertiary will not give any positive results with this carbolamine test. Next question, write a chemical equation for the conversion of 4-nitrobenzene to aniline. 4-nitrobenzene, we can use a different catalyst, so we can get a same product called as aniline, but the reaction will vary. So, you can see with the first reaction, if I take a nitrobenzene in presence of an acid, that is addition of hydrogen in presence of palladium as a catalyst, it gives to the aniline with the formation of water. If I carry out the same nitrobenzene with the stannous chloride with a concentrated HCl or iron with a concentrated HCl, it can hydrogen to the benzene ring and forms the aniline with the formation of water. These two reactions you can remember out for writing the how nitrobenzene is converted into aniline. Next question, why primary amines have a higher boiling point than the tertiary amine? It is very important We know that all the amines except tertiary amine, it can easily form a hydrogen bonding with the water, correct? Due to the presence of what? Polar NH bond. Due to the presence of polar NH bond, it can easily involve in a bonding and forms a hydrogen bonding. Correct? No. That is why the boiling point is raised gradually with increasing in molecular mass. Therefore, we can say that the boiling point is less for the tertiary amine than the primary amine than the secondary amine. This is due to the intermolecular hydrogen bonding, that is due to the polar NH bond, and order also I have written primary is first, then with secondary, then with the tertiary. Next question. Write the Hawa structure of lactose. Here I have written the Hawa structure of lactose. Both are the beta D galactose and the beta D glucose. When we combine, it gives us to the lactose structure, where you can see that 1 and 4 carbon atom is connected to the oxygen atom, and it gives us to the Hawa structure. Any one of the Hawa structure can be asked, even for glucose, even for fructose, even for maltose, galactose, even for lactose, even for starch also. Try to practice it. Next question. Name the nucleic acid which is responsible for genetic information. We know that DNA, that is deoxyribonucleic acid, which is mainly responsible for carrying a certain characters or a genetic informations from one generation to another generation. Next question. Name the vitamin which are responsible for coagulation of the blood. Vitamin K or vitamin K is an vitamin which are responsible for coagulation of blood. Give an example for naturally occurring optically inactive amino acid. Optically inactive amino acid is glycine. There are 20 different amino acids will be there. Any one of the amino acid, either basic, acidic, neutral, even optically active, optically inactive can be asked for the exam. Try to make a list about it. Next question. How Buna S is prepared, and write the equation. And this is a question from the polymers unit, and it is very easy to write with the preparation of neoprene or with the Buna and Buna S, acrylonitrile, even with the nylon 6, nylon 6. Many preparations are there. Try to make it with your own way and try to practice with an example. Here, when we take the mixture of 1,3 butadiene with the styrene, okay, you know what will happen? It gives a butadiene styrene copolymer with the shifting of only the double bond, and you can see that how this double bond which has been shifted in the 1,3 butadiene and it has been placed between the second and third carbon atom. This is just a copolymerization which has been done by taking these two mixture. Next question. What are homopolymer? Give an example. The polymers which are made by addition of polymerization from the same monomers are said to be what? Homopolymerization. If you wanted to do the polymerization process, if you take the same monomer and if you continuously add them, it will become what? Homopolymerization. There is one more method known as a copolymerization, where we are taking the two different types of monomers. But in the homopolymerization, we are taking the same type of monomers and we mix them with under certain conditions, and we are getting the same polymer of the monomer. Okay. So, here ethene I have taken. Ethene is mixed with the other ethene to get a polythene. Okay. Next question. Write the IUPAC name of isoprene. The IUPAC name of isoprene, it is nothing but 2-methyl 1,3 diene, or you can write the structure also 1, 2, 3, 4. 1 and 3 should have a bonding, double bond because it's a diene. Then satisfied with the hydrogen atom CH2. Then it is 2-methyl, that is CH3. Then with a H. This is CH2. That is 2-methyl 1,3 butadiene. Correct? 2-methyl 1,3 butadiene. Okay, this is the IUPAC name of the isoprene. So, this is all about the just an outlook about the model question paper which has been released from the board. I hope that you have understood with the pattern of answers that you have to write for the final exam, and refer the previous year question paper with the pattern of question which has been raised from the 2 mark, 3 mark as well as for the 5 marks. You will get an idea. For choose the correct answers, what are all the board which has been released chapter wise. Choose the correct answers or multiple choice questions, refer those questions and go through with the other model question paper from the other districts. You will get an idea. I hope that you have understood with the model question paper. See you with the next class. Till that, take care and thank you.